Okay, for this tutorial, I'm going to move into the dealing with numbers and mathematics, basically. Although I'm going to start with the nice, well, you just do this nice simple maths. Complicated maths, Visual Studio has a whole bunch of built-in stuff. So as before, CA for console application 3, and then I'm just going to call it calc because it's something nice and simple that I know. And I'm going to create a new project. And I shouldn't have gone to open resource, I should have gone straight to create new project. So as we've been doing before we've been doing C# console applications, which of course, okay, it remembers the type I've been using. Next, CA3 for my third console application. In this case, it will be calculations. And that should pretty much do it. Create. So you notice where it's been deposited for the repos. It's great if you want to chase up your code and actually have a go at the thing in a later period of time. So here you can see it's set up the basic console application. If I jump to here, I get to my random video directory, but if I paste into this, no, that doesn't work. So I will go to where the repo is located, which will be in here. There's a couple of places to get to it, or ways to get to it, but basically if I copy the full path and paste it into here, delete the end bit because that's actually a file name .file extension type. That brings me to the folder it's in. If I actually go one level up, you can see all that, and these are all the examples I've worked through previously. So I'm basically just updating this stuff for Visual Studio. And if you double click on the SLN file, that's the solution file that contains everything, links to everything that exists for that solution. The actual files that it needs are all located in here. So when you end up submitting work to show it to me, just go one level up from the solution and then just compress that, send to compressed folder, make it into a zip, and that way you can submit it with all the associated files. Because if you don't do it that way, you'll end up losing attached images or whatever else you've used, sound or whatever, in that file, and it's always worth having. But anyhow, back on with the simplicity of what we are doing. We are doing console applications, and I'm just going to leave that line there. Because this is our introductory program, and we're going to start actually extending on what we've done before. So for the math side of things, you should know the basic 4 maths operations, which are addition, subtraction, multiplication, and division. There's also a 5th one used in programming called modulo, but I'll get to that in a moment. Let's start with the basics. So as before, I'm basically just writing a question, type in a number and finish it with a semicolon. There's the statement. I need to create my 3 variables. Should have done that first, but declare variables. So I have I1, which is my first integer. And I should have remembered how I declared it from last time, because it's pretty simple. Int I1 equals 5. Actually, we'll go 3. So I'm declaring an integer, and this one is called I2, and it's equal to 3. I wanted that one 5 because that ends up with some interesting maths, and if I could spell right, that'd be easier. Int I3 equals 0 for now. We'll get back to that. 3, not tree. What you'll notice is I'm using camel case, and I talked about that in the last tutorial, or at least I should have from memory, which was a few weeks ago now. So let's jump on to what I'm going to be dealing with. So that's all set up. I don't actually need this line here, so I'm just going to get rid of it. And then we start into our program proper. So the variable I3, this is going to be used in an interesting way. What I need to do is I need to take a piece of input, in this case from a readline statement, and I'm actually purposely doing this incorrectly because, great, I'll let that just sit in the background for a minute. If I run this as it is, what I'm trying to do is I'm trying to read a string value or a bunch of characters and put it into an integer. The two types don't match, so there's going to be an error. I need to convert this. The process is generally referred to as casting, but in this case I have to use a special function called int32. I'm just going to leave a space there. And then I'm going to parse it. Now int32 has a function within it called parse, and so what it will do, if I can spell that correctly, P-A-I, well maybe I did, parse, close bracket, and then close that end. So what should happen here is what I type into the console should be read and then converted into a number. And I will test that by trying to break it. So here it's a simple little test. Should start up the application in just a moment. And if I type in a number, give it a second, thinks about it, please. Yes, excellent. I'm going to type in 5. Did that work? Excellent. Run it again, this time I'm trying to break it. 5.dfj. Crash. It should crash at this point. Please crash. Yes, because it can't deal with it. So we'll get to how to deal with crashing later on, but when people are being purposely destructive to your program. But, and I also need to stop it running in the debug mode. How on earth do I do that? No, I didn't want to continue. I want to stop. And I should just kill that. And it should, yes, flicks back. Great. So you notice the different layout here. It's amazing what 2 weeks of holidays will do to your brain with this sort of stuff. All right. So now I need to start getting into the actual math stuff proper. So I need another variable, which is going to be an integer called ianswer. And I'm going to make that equal to 0. Now, that was coming up an error here because when you name a variable, it has to start with a lowercase in C#. Well, it's actually in C, but in the C family of languages. So what I'm aiming to do here is be consistent about what I'm doing. So ianswer is going to get some basic maths. 1 plus I2. So you can see here instantly that ianswer should be assigned the value I1 plus I2. Nice and simple. So it's like the maths you would have done through most of high school, except that all the calculation that happens on the right-hand side is resolved before being put into what's on the left-hand side. And most programming languages work this way. I cannot offhand think of an example that doesn't, but I'm certain somebody will be able to find one that is distinct. Now we need to output the results so that people can see what we're talking about. So again, we're doing a right line statement. And at this point, things are going to get a little bit different to what you're used to. You just have to trust me on this phrase. And I'll show you how to construct it. Whoops, I just hit the wrong button. Okay, so the $ quote means that within the quote marks, you'll be throwing in variable values as well. So I1, and the variables need to appear within the curly braces. ianswer, and that should then resolve. So that's enough for now. So we'll just test it again to make sure it's working. Does its build, runs through the sequence, creates the code. I'm going to give it number 5 and we'll just move on here. Okay, so we've got 5, add 3 equals 8. That's perfect. So that bit is done. And now one of the greatest things ever invented in computing, and I really wish I could remember the person's name who did this, is the copy paste. But all I need to do, so it doesn't do the things, I'm going to start demonstrating all the other maths. Basically, I'm going to get it to do all this math stuff here. Oops. All right, and then I need to do star for multiplication, that slash symbol for division, and the percentage sign for modulus. So divided modulo. Alright, so run this again as just a part of a testing regime, and it all should appear. I'm just going to go 5, go, and we have 5 subtract 3 equals 2, 5 multiplied by 3 equals 15, 5 divided by 3 equals 1, and obviously 5 divided by 3 is 1.666 reoccurring. And then we get to modulo, and this is why I waited to this point so you can see the example here. 5 modulo 3 equals 2. Modulo is the remainder, what is left after when you do a division operation. So you can see the 2 directly after the other, that, you know, 2 over 3 or 0.6666 reoccurring is 2/3, right? And that's what modulo gives you. It's really good for detecting positive or not positive negatives, odds and evens, or, you know, certain numerical factors, and that is actually really beneficial in some cases. So moving on to the next bit, as I showed you last time, we have console.thread. No, I've stuffed up because I can't remember what the threading is. Should have looked this up beforehand, but hey, it's all there. Oh, I suppose I can, yeah, do the, yes, I'll do the wait for a response. Right line, press any key to continue. Hopefully they know where the any key is. And then console.readLine. Alright, and that'll give us the phrase that we need. Now, you'll notice up the top here that I have given you the information you need to assign an integer to i3. And you'll need to go through and rewrite this section so that it will do the maths on I1 and I3 as opposed to I2. That's a simple cut and paste job. I'll leave it up to you to do that. It's a good way of challenging and testing your skills to see if you can make this thing work on your own. Have any questions, again, ask me in the comments or catch up with me in class. And that's pretty much the core idea in this program, is to get used to using some of the maths. So what we see here is the basic structure of mathematical calculations. Now, if you want to take it a step further, there's also BOD maths. So we've got brackets, multiplication, division, subtraction, and addition. Yeah. And so any brackets are resolved first. Then all your multiplication stuff is resolved first. And for a computer, it needs to resolve this because there can be no ambiguity about how things are done. So when it does these calculations, it goes, all right, do we have any multiplications? No. All right, we'll start from this side, start from the left, move across to the right after the equal symbol, and resolve each collection of terms. So if we wanted to get something a little more complicated, we can basically do... That's right. Equals. All right, so what are we going to make it equal to? I'll just give you an example. I1 times I1 minus I2. Now, you can see this is here, and these statements can get really, really complicated, but this was just a nice, simple example. And I'm just going to drop in the answer here because I really don't want to worry about the rest of it or what the actual operation is going on. But if we do this and then quickly add in the 5, all right, so what we have is an answer of 10. And if we look at the breakdown of how this happened, we've got 1 times, so 1 minus 2 in brackets, well, in this case it is 5 minus 3, which is equal to 2, then multiplied by 1. Now if we remove these brackets, and I can't do that until I finish the program, and yep, get rid of all that stuff, what we'll see is what I'll do is actually go minus I2. So in some cases it's really tempting to Yeah, that's perfect. What it will do at this point. What is the answer? So give it a second, try and work it out in your head. Follow those rules I've just mentioned of how these things resolve. In that, 5 minus 2 multiplied by 5 minus 2. And there are multiple possibilities of an answer, but the computer always has to arrive at the same answer. It always has to be nice, clear, and consistent for it. And it hits minus 13. And you might go, what? But let's have a look at what we've got here. So the multiplication is resolved first. So 2 times 5. 2 5s are 10. Great, that's resolved. So we drop that in the middle there and replace it. All right, what's next? Well, it's all minus signs. So it's, 5 minus 10 minus 2. That seems wrong. I may have just miscalculated this. But anyhow, because 3 times 5 is 15. So 5 minus 15 minus 3. Well, let's start. 5 minus 15 is minus 10. Minus 10 minus 3 is minus 13. Great, we get to the answer. So you can see here how it resolves things in this sort of process. And it's worth knowing and worth sort of getting comfortable with that. So I'm just going to get to the end of this. And that's pretty much it for this program. And next time we'll continue with more. Again, any questions, hit the comments and we'll go from there.